We are thrilled to be here to talk about Snowflake Openflow that Joe and I and many of us have been cooking over the last 6 months. We have some exciting details to share with you. Why we started building Snowflake Openflow. Matt talked about Openflow being a data ingestion service. Joe and I think Openflow is a movement service. We will move data from anywhere to anywhere. I'm Saptarshi Mukherjee. I lead the product management team for our data movement, data ingestion, data integration product areas. And I'm joined by Joe Witt.
Great to be here, Sap.
And Joe is the co-creator of Apache NiFi, leads engineering. Awesome. Joe and I, we have been talking to many customers over the last 6 months, talking to them about their AI challenges. Majority of our customers that design their data pipelines with a BI and data warehousing world in mind. Data used to come overnight, gets processed, and get ready for a BI dashboard for human beings to look at. Today, you heard Sam and Sridhar talking about the world where AI agents are going to continuously reason about data, generating in multiple enterprise systems simultaneously. You cannot afford to have data pipelines and ETL topologies that were designed 20 years ago. You need to converge all of them into a modern, open data movement platform, and that's Snowflake Openflow. We move data, all data, batch, streaming, structured, unstructured, multimodal data from anywhere to anywhere. We move data from SharePoint and Box to Snowflake. We move data from Postgres to Snowflake. We write data in Iceberg in S3 using one single homogeneous service. It's going to radically simplify the way enterprises are managing their pipelines to move data around. We just don't bring data from an application into a lake. We move data from a lake into an application because AI agents need to make decisions that will get activated through a business application. So this is what Openflow does. It helps you to connect to your factory floor for MQTT data. It lets you connect to your business applications, most important SaaS apps, core business apps that are running on systems like Oracle. Get all of that data, including unstructured data, multimodal data, into Snowflake for data engineering, analytics, AI, and ML, and then make that insight available into downstream applications for activation purposes. And we'll see a live demo. That's the whole purpose of the Builders Hub. We'll see the product in action and how we are ingesting data and then making that actionable. So let's switch to the demo screen and just quickly see what is Openflow first before we talk about the demo scenario. So you come to Openflow. This is the Openflow landing page. We get to see the documentation, the support link here if you want to get some support quickly, and then you launch Openflow from here. You launch Openflow, you come to the Openflow user experience. In Openflow, there are some core concepts. The first concept is you have deployments. Deployments are namespaces. Openflow can run in Snowflake's own VPC in SPCS. You can deploy Openflow in your own VPC in cloud service providers today. You can deploy Openflow in the future in OpenShift on-prem clusters for you to run pipelines closest to your data sources. So deployments can be hybrid. You can run multiple deployments for Openflow and govern all of that from a single control plane. It's a single pane of glass to deploy your data planes globally anywhere. Within each namespace or the deployment, you have runtimes. Runtimes are compute unit that executes the connector pipelines. And Joe is going to go into the details showing deploying a connector into a runtime. A runtime can horizontally scale. So we are designing Openflow with cost and efficiency in mind. You can do bin packing of running multiple connectors in a single runtime, or you can essentially define a connector runtime elastically with minimum and maximum node size. Depending on data load at any point of time, the number of nodes will dynamically scale in a given runtime. It's truly game-changing. Let's come back and see if you are a user of Openflow, you will get to see the connectors that are available in Openflow. We have connectors for SaaS sources, for streaming platforms, unstructured data. I'll talk about unstructured data. It's very important. For example, we have connector for Google Drive. We are not just replicating files from Google Drive into Snowflake. In the process of that replication, we use Cortex to do parsing of files, we do chunking, we do vectorization of documents, and we write vectorized data in Snowflake along with the source system ACLs and permissions, so that when you're building a RAG applications on top of that data, the RAG application can be source system security aware. So if a user has access to a file, a read-only access in Google Drive, only those users will be able to interrogate that data. It's all built in within the connector without you moving needles. That's very powerful, right? And then we have simple ingest. For example, you just want to land the files and you want to do your own chunking, parsing, vectorization, you get the full flexibility. We will talk about the extensibility nature of Openflow. We have connectors. We will have 100-odd connector by end of this year, but Openflow is fully extensible using Apache NiFi SDK. You can start building your own connector for any arbitrary source. We support generic HTTP endpoint, JDBC drivers, and you can build your own connector and deploy that in the fully managed service. In order for you to deploy a connector, you go and click on that connector, and you select a runtime on which you want to deploy this connector. And there you go, the connector is deployed. You can configure the connector and start using it. Those who can deploy the connector in a runtime, it depends on their role-based access control. So we have integrated Openflow's RBAC and governance with Snowflake's core RBAC. Think about it. It's extremely powerful because none of the conventional ETLs, they intertwine with the data lake RBAC policies. So this is very powerful and heavily requested. Now I'll come back to the original demo and the story. So I have to go back to this just to explain the context, and then I'll let Joe go into the deeper aspect of this demo. So we have a fictitious auto company called Acme Auto. And by the way, this is a real conversation, similar conversation we had with a global auto manufacturer. They are launching new vehicles in a market. They want to get sensor data coming from those new vehicles because they have heat sensors. Depending on the weather condition in the new market, there could be some potential problem. They need to adjust the coolant level in the engine. So before the car breaks down, they want to get that data. They want to do analysis of that time series data in near real time through a Cortex agent. And then they want to send the dealership a notification that this car requires an adjustment of part A. And that requirement, what needs to be done on that vehicle, is going to come from insights that is coming from Box. Box is a launch partner of ours. Service mechanics in other geographies, when they have performed similar fixes, they have loaded such data in Box, right? So we need data from Kafka, engines data, sales transaction data from Postgres, and then data from Box. Let's go back and make this happen.
Love it. All right, so as Sap just set up the context here, we have 3 different flows that we have to build. The way to think about Sap's intro there is he's essentially the data scientist or the person that wants to use this information to provide insights to the business. I'm on the other side of that spectrum. I want to be the data engineer, finding that information and serving it so that he can do powerful things with it. So this is where I'm going to come into Openflow with my data engineer hat on, and I'm going to think, okay, how am I going to start connecting to Postgres? How am I going to connect to the right Kafka clusters? How am I going to interact with systems like Box? And so just to get started, I know I need a place to run this. And so I'm going to create a runtime here just so we can get things going. A few things that I'm going to think about. The first thing I'm going to think about is where does it need to actually operate? I've been in a tremendous number of customer conversations, especially over the last couple of days. And what we hear time and time again is they need us as providers to meet them where their data is. Offering managed services through Snowflake's powerful, but a lot of these use cases require us to install in the customer's cloud account, whether it's on AWS, whether it's Azure, GCP, you name it, they want us to be where their data is. And there's a number of reasons for this, not the least of which includes that sometimes you got to filter out that information before it can be sent to downstream systems like Snowflake, or you want to enrich it so that by the time it lands in Snowflake, critical information is provided. And then there's also really important security reasons that you might do this. You may have network rules that allow your customer-specific CSP accounts to reach on-prem environments where you can pull that data and then publish it to Snowflake. So BYOC is a critical part of us doing what it takes to be where the customer needs us. And so first, I'm going to run this in US East. That's where it happens to be that I need to run these cases. I'm going to call this Builder Hub. And I'm going to pick the node type that I want. It might be a small use case, might only require a single core or so, very limited memory. And I want to really control costs. I don't want to necessarily blow out the budget here. And I might choose small. Or I might choose small because I know that I'm going to get really powerful elastic scaling automatically from Openflow, where it's looking at things like CPU usage and deciding when do I need to go ahead and scale up nodes. This would be a really common configuration, for example, when pulling from things like Event Hubs or Kafka or systems like this, where we can really naturally scale the number of consumers. And I can do that very easily by just clicking over here. I'm going to start with a minimum of 1, grow to as many as 10 in this case, start to specify some of that role information. That's who the owner is of this runtime. And then as Sap said, I can also go in and decide who else in my organization, based on their roles, is going to have access to use this same runtime alongside. So I'm going to go ahead and hit create. This part always makes me laugh. It's basically saying, hey, this is going to take a while. Would you like to do something else in the meantime? And so here we're going to start browsing connectors. I could view runtimes, which is what this screen behind here is, or I can browse those connectors. So we already said in this flow we want to talk to Kafka, Postgres, and Box. They're all right here. It's very simple. So boom, there's Kafka. I would add that to a runtime. I've already done this, so I'll show you that in a second. Box I would grab right here. And what's the other one? CDC, how could I forget? It is somewhere around here. Add to runtime. Or it's probably a featured one if I go to the top as well. And so I've already deployed these. And so I'll do that here. Meanwhile, that Builder Hub runtime that I mentioned is being created right now. It takes a couple of minutes depending on the size of the runtime and how much scaling is going on in the background. But we'll pick a couple of these. So I'll hit this box one first and give you a sense of what that looks like. Keep in mind, it feels like I'm in Snowflake, but I'm actually interacting with resources in a cloud account. It's pretty sweet. And so here I can go at the very high level. I see this green check mark. It's showing me the things are running. I can see, frankly, a very small amount of data in this case. There's been no changes. Here's our box data in our Acme Auto example. All the service manuals are here. There's nothing that's been changing. But if I go in here and change even just like permissions or add metadata, it'll still catch that too. We grab content and context in pretty much every case. And so that flow right here is tied to that data source. Or we have use cases or data like we're pulling from MSK here. And so we could take a look here and now get a really quick sense of exactly what's happening. And so I just know right now at a glance, in the last 5 minutes, we've pulled just under 100 megabytes of data. I could look at really compelling information. I could also make immediate changes to this. I could stop it. I could add a transform step. Really commonly here, might want to filter out columns, add new columns. I might want to convert formats. Maybe it was coming in some goofy CSV and I wanted to put it into a goofy JSON or whatever. I could do all of that right here at a glance. I can also get really good information about status. So I want to see, let me see, let's look at some latency information because this is kind of important. This graph looks a little funny, I'm sure. Maybe if you're further away, it looks really smooth. But I can just very quickly get a sense that we're running somewhere in the 50 or so millisecond average range for latency. That's data being pulled directly from Kafka. That's exciting, but I actually want to know how long does it take to get to Snowflake because, you know, it's a near real-time case. So I'm going to look at status history here, and I'm going to do that same metric, and I'll find it. Average lineage duration, that's a fun one. And now we're looking like we're sitting around 2 to 2.5 seconds. The average is a little over 2 seconds. And so I know end to end, from the moment the data was sitting in Kafka to the moment that I've delivered it all the way to Snowflake, confirmed delivery, that we're sitting at about 2 seconds on average.
With Snowpipe Streaming V2, coming in, we will support up to 10 Gbps throughput per table. With Snowpipe Streaming for Kafka Connector and Openflow, that's going to be game-changing.
Yeah, and it's really actually quite awesome to watch it scale on here. You can see exactly these charts that we're looking at. You'll watch the numbers scale up really high. You'll start to see on these, I'm going to zoom in really far here, but where it says 97 megabytes in the last 5 minutes, you'll start to see hundreds of gigabytes. It's pretty awesome. The data volumes are pretty staggering, but I'm just looking at a high-level UI here. How do I even know what the data is? Well, that's easy too. I'm just going to go right here, view data provenance, and I'm going to say I want to look at one of the most recent events. And I could just, boom, click to content. And right there, these are the events as they're streaming in right now. I know exactly what this particular event said. I can actually see that it's a bunch of events. For those of you familiar with Kafka, when you go to the well to read once, you're actually reading lots of things at once if you're doing it right. That's what this is showing you here. And we have a bunch of events all in the same bundle that I can very quickly see and understand what happens to data. I can also look at the other metadata that I pulled, all the Kafka headers, partition information, topic information. It's awesome as a data engineer to get into this level of detail. Again, this isn't like something that happened at some point. I can look at this right now in real time. Really powerful. Now, this level of detail is something that I might want as a more like hands-on or power user type data engineer. That box use case is maybe simpler. In the box case, I'm a higher level data engineer. I may not need to get into the details. I may not want to write code or may not even be able to. I can just interact with Openflow using that technique. Just deploy the connector, provide my box credentials, my Snowflake credentials, and hit play. Whereas in this Kafka case, it's much more nuanced. I'm almost always wanting to manipulate the data in some way, almost always wanting to filter or transform or something, and I can just weave that in. And to be clear, it is literally like this, where you're just saying, I want to do some record transform. So I'm going to search for record processors, do all kinds of stuff. Here's one that's interesting. I can convert records. I could run SQL commands over the data. We wouldn't be Snowflake if we didn't add SQL in there. And then I could do all kinds of things like forking and partitioning and really powerful things, geo-enrichment, all kinds of stuff.
I mean, this is the most important thing that is coming up with a lot of developer conversation. I mean, we will offer connectors out of the box, but you can start forking and adding new processors. Depending on the Kafka topics, you can write part of the data into Snowflake. Other part of the topics can go into Iceberg in S3. This can happen on the same managed platform in a matter of minutes versus you trying to create a connector from the ground up. That's extremely powerful.
And as Snowflake, we want to make things super easy for our users, as you know. And so the first thing to think about then is I want to give you pre-built connectors out of the box that are going to do the right thing. This one, for example, is the Postgres connector. It will do CDC for real out of Postgres, drive that data into Snowflake. And I have immediately, just at a glance by looking at this one, I see this green check mark on the top left. That's telling me that I'm tracking the right version, meaning this is the version of the connector that Snowflake published for me as a customer. I know that I'm using the right version. I haven't changed it or deviated. But if I wanted to, I could. I could say, hey, thank you, Snowflake, for giving me this flow. But I'm going to now edit this and customize it. I might jump into this incremental load step and make some configuration change, which I can, again, do in real time. Those changes that I make in the flow then are represented. I could throw things like, I don't know, I'm just going to put something on here for fun. But these things immediately start to reflect changes that show up to me on the UI. And now that green check mark is basically saying I've deviated from what Snowflake gave me. I could look at version control information and say, hey, I'd actually like to see what local changes were there. And boom, I see a processor was added.
Joe, the data scientist is getting impatient. We need to show what do we do with the data.
All the data's there now. Over to you.
No, awesome. So Joe got all the data into Snowflake, but I think, as I said, like you will have a human in the loop, right? The AI agents are going to reason about data coming from multiple sources simultaneously at massive scale. You can essentially have, I mean, this is a demo app that we built to show you like the data coming in from Kafka topics. We can have, you can write questions and get answers by pressing questions to the Cortex chat agent. We can have human in the loop to make sure. So I can ask, what are the 3 vehicles with most alerts? Right? So now Cortex is reasoning on data in real time coming from Openflow. This is where the power of Openflow plus Snowflake comes into foray, right? These 3 win numbers are getting the maximum number of alerts. You can look at the SQL query that was generated by Cortex. You saw that we announced this capability from the keynote yesterday. But we didn't stop this with Openflow. I said we can move data. We save this, and an agent is going to write this, and then the agent is going to send the notification to the dealership with the service manual that they need to have so that the vehicle, when it comes for the servicing, the service representative is ready to work on this, right? So that's the powerful thing that Openflow is able to do. We have a bunch of sessions coming up on Openflow where you can learn more. We have connectors for SaaS, unstructured data, databases, streaming, all available now. And then we are going to build many more. This is the roadmap of all the connectors that are going to come in the next few weeks and months for SaaS, streaming, unstructured, SFTP, FTP, MQTT, all the gory protocols that need to be connected with Snowflake. We are thrilled to announce we have a partnership with Oracle. If you are using Oracle, you will be able to move data from Oracle into Snowflake using Openflow. We have a ton of SI partners who are ready to help you move your pipelines to Openflow, help you build new connectors and connectivity pipelines on top of Openflow. We can't wait to see what you do with Openflow. Thank you so much for joining us here. Thank you.